Okay.
Farther is F-A-R, far. T-H-E-R. Give me maybe 2 more minutes. Okay, just hold on to it. What else could it be, Mabel?
There's nothing really else because it's not light except for the other lights.
Okay. What do these mean?
Those are the lights.
Oh, okay.
This is dimmer.
Alright, finish up your sentences.
How do you spell father?
F-A-R. T-H-E-R.
Dad, do you spell light L-I-G-A-H-T? That is how you spell light.
L-I-G-H-T. Yep. Okay, let's pause for a second. Or at least like finish the sentence you're on. So I noticed that all 3 of you said something about the light being farther away, and that's why it's dimmer. What else might it be?
There's less power behind it.
What do you mean by less power behind it?
Like there's like not very much power. Like it's like this is a bright light and it's at full and it's at its lightest.
It's like its brightest.
And that's at its dimmest.
Ah, okay.
It could be because it's losing battery.
Oh, okay.
I actually think that light way back there is brighter.
Oh, really?
But it's just so far away that it looks dim.
Oh, that's interesting. Okay, but there's definitely something about the brightness of the light and the distance of the light that affects how we see it. What questions do you have about that? So now we're going to kind of switch gears. Alright, so I'll take the pencils. And your sheets.
One side is all lighting and one side is all picture.
And so here, I want you to take a look at, actually before I show you that, when you think of the sun, I think you guys know that the sun is a star.
Yeah.
But like, what's different about the sun, like when you think about the brightness compared to other stars? Mabel.
The sun is a fireball, and the stars are little like fireballs. So since it has so much fire on it, it's brighter.
Okay. Cash.
Well, actually, the stars are actually as big as the sun. It might be even bigger.
just they're way farther away. Like,
Oh, that's
like
interesting.
galaxies away.
Okay. Lincoln?
Same thing as Cash. It's just they're possibly light years away.
Okay. So, go ahead, man.
The stars instead of the sun, I thought maybe even planets and other galaxies that we just can see as tiny dots.
Okay. So what I'm going to show you here is a spreadsheet. Can you guys see those numbers?
Mm-hmm.
If you can't, I'll move it a little bit forward. And if you need to slide forward, that's okay. So these are different stars. And this is what we call the actual magnitude. So that's how bright the star is. It's kind of like when we did on the bike lights. Everybody look at me. There would be magnitude 1, 2, and 3. Okay, the higher the magnitude, the higher this number, the more clicks kind of on the bike light. And so when you look at the star or the sun,
It's 4.8.
but it's negative 4.83. And then look at Rigel. Rigel is 6.69. So between the sun and Rigel, which of those do you think is brighter?
Rigel. Way brighter.
Okay, by a lot, because a negative number is a really, really low number.
And the star's still.
It's below 0.
And the sun's still so bright that we can't look at it.
Okay, so now if the sun is so if we look at Rigel, or Betelgeuse, which is at 5, or Canopus, which is 5, those are stars that are out in the sky that we can see. Why is this? But the sun is way less bright. Why does the sun look so much brighter than the stars? Mabel.
Because the sun is what lights up our day, and then we think it's brighter. The sun's brighter because it doesn't need stars to go with it. But the moon needs stars to go with it because the moon isn't very bright.
The moon's not very bright, but the moon's also not a star. And so why does the sun star look so much brighter than the other stars? What do you want to add, Mabe?
It's closer to our Earth.
Okay, Lincoln?
It's probably only a few million miles away.
Okay. And so if the sun is closer to us, even though it's not very bright, right? Because that's what these numbers mean. On this list, the sun is the least bright, but it looks the most bright. So now we're going to take a look, we're going to add something. So this is the apparent magnitude. So this is how bright it actually is. This is how bright it looks. Now what do you notice about the sun?
It's the brightest on the list.
Okay? And so the apparent magnitude is how bright we see it. So this is how bright it is. This is like how many clicks on the bike light. And this is how bright it looks to us, which is affected by things like distance.
Wow.
So look at how dim all these other, so now, what questions do you have about these columns so far? We're gonna use them here in a second. Go ahead, Link.
I have no questions, but I have a comment.
Yeah.
All of those are either 0 point something, 1 point something, or in the negatives.
Yep.
Or negative 0.3.
And when you think about stars, even though sometimes they look really bright and pretty, they're still kind of dim and far away. Whereas the sun, like you can't even look at the sun. You'll hurt your eyes.
You're gonna get blinded.
Mm-hmm.
But then if
What
you're
other
blind,
thoughts or
you
questions do you
can't
have about
see
these so far?
No.
Okay, so now we bring in the distance. So this distance is in light years. So light years is a big
Huge.
distance. And so the sun is really close. It's a small distance. But then if we go to Rigel, Rigel is 770 light years away. I think that's the farthest on the list. So Rigel is the farthest away.
And it's the brightest.
But it's the brightest, but look at how dim it is. Why is it so dim?
Because it's the farthest away.
Because
so far
away.
Okay? And so the sun is really dim, but it's really close. So why is it, so it looks really bright?
How many miles would that be?
I honestly don't know. I think the sun is 93 million miles away.
Okay.
I'm not 100% sure about that, but I think. All right, Cassie, sit back. All right, so what questions do you have about how distance and brightness affect the stars that we see?
None.
None.
Okay, so this next part's gonna take some thinking.